This is a video on parts of a circle. They're going to be doing a couple of different answers here for below proficient and approaching proficient. The below proficient question is, what is the center and radius of the following circle? You need to know what the general equation of a circle is, and it's x minus h squared plus y minus k squared, and that's equal to r squared, which is the radius squared. This actually comes from just the Pythagorean theorem. If I think of as a circle, let's move that center, as a circle as being all points that are the same distance from a central point. If I wanted to look at this point, we call the center of that circle HK, and we'll call some random point, let's call that point right there, some point on the circle x comma y. And so I could look at this little right triangle that we form here, and this would be the radius. This distance right here would be the difference between the x coordinates. So it would be that distance would be x minus h. And this distance right there would be the difference between the y coordinates, or y minus k. And that's how you would find those. But then you use the Pythagorean theorem, and so you're going to take A, let's say A here, and B here, and C here is the radius, and then you're just going to square them. So x minus h squared, y minus k squared is equal to the hypotenuse, or r squared, and that gives us the equation of the circle. So it just goes back to the Pythagorean theorem. Now, the center is at HK. The center of this circle is h comma k, and the radius is r. And so if this is r squared, you have to just take the square root of that. Now I'm going to rewrite this equation to help us to kind of see what's going on. X minus 14 squared, I'm going to write right here, x minus 14 squared plus, now instead of just writing y squared, I'm going to write that as y minus some number something squared. Now if I didn't have anything right there, it's the same as like just having, just y squared. That's what we have, y squared. So I'd say, well, what would that not having anything be? Well, it would be the same as y minus 0. So I'm going to write that, y minus 0 squared, and then that's equal to 9, but I'm going to rewrite 9 as 3 squared. And so then I can see that the h coordinate here is 14. It's like a lot of these that we've done, h and k are kind of counterintuitive. And so h is 14. And then let's say k would just be 0. So there's my center. It's at 14, 0. What's the radius, you ask? Good question. The radius is that number squared, and so it's 3. And now on this next part is a lot of vocabulary. Given the following lines, angles, and arcs, match them to their part of the circle. So let's look first. Central angle is an angle, as the word would indicate, at the center. That the angle, the vertex of the angle, is at the center. And so this center of our circle here, and it's sometimes it should say this is circle P, and that circle P is named by the center. So P is the center of the circle. And so I could say there's a center angle right here, APC. I could say a central angle here, CPF. I could say EPF or FPE. I could also say EPA or APE. And any one of those would work. And so the important thing is that your vertex is in the middle. So I look up here and I go, oh, wait, EPA. So that is my central angle. Now, an inscribed angle is an angle whose vertex is on the circle. And I really only see one of those, and it would be, the inscribed angle would be this right here. And so the center of that angle, the vertex of that angle would have to be E. So look at angles. This one, no. E right here. Okay, so that's it. B is right there. Now, a major arc and a minor arc. So first off, if we look at these, there is an arc and there is an arc. If you were just hand drawing it, it would just kind of look like an arc. A major arc is the one that goes like the furthest distance around the circle. And so AGE, if you were to look at AGE, this A that it starts with, and then it goes to G. So from A, it goes over here to G, and it goes the shortest distance, A over here to G, and then it continues on through to E. And so it goes over here to E. And that, from here, all the way over here, that's the arc. That's the major arc. And so major arc would be C. Check. Now, minor arc. A minor arc is one that just kind of goes directly there. And so for that one, you don't need 3 points. FG, that would just be right here. That little thing right there is FG. And so that would be the minor arc. And we put that right there. Okay, so a chord. Now, a chord is a line segment that connects 2 points on the circle. A diameter is a chord. But since there's already a place for diameter, because it connects here, let's see, E to C, goes through the center P, that's a diameter. Also A to F, that's a diameter. But diameters are also chords because they are line segments that connect 2 points on the circle. The diameter is the longest chord that's possible in a circle. So, let's see. And I don't think either of those are probably going to be what we're looking at. Since diameter, let's say AF. There we go. From A to F, that's my diameter, G. G. And then a chord that is not the diameter, remember that let's see, a chord, a diameter is a chord, but not all chords are diameters. And an example of a chord that's not would be this E to G, connects these 2 points on the circle. And so EG, that's E for chord. And let's see, tangent. Let's go green here. Now a tangent is a line that touches a circle at only 1 point. So this right here is a line that only touches this circle at just that 1 point, at point C. And so it's a line, and it goes through points B and D, B and D. They could have called it BC, CD. They could have called it any one of those, but they named it BD, and so that would be F is tangent. And then PC, let's see, is the only one left. So it looks like that's a radius. A radius is the point from the center of the circle to any point on the circle. So the radius, H, is from P to C. They could have also said P to A, AP. They could have said PE or EP. They could have said PF, or they could have drawn any one. Like if I went over here, P, let's say this was Q, they could have said PQ is a radius. Any one of those points that goes from the center and touches the circle, that is a radius. All right, there you go.